I am Dr. Naveen CS, working as assistant professor in the Department of Physics. Our aim is to study the IV characteristics of a given Zener diode and to determine the D voltage, forward resistance, and breakdown voltage of a given Zener diode. To start with, first we have to construct the circuit diagram. This is the circuit diagram for forward bias and this is the circuit diagram for reverse bias. Now I will show you how to construct the circuit. You can see there is a regulated power supply which varies from 0 to 20 volts. I am going to connect this regulated power supply to the circuit using the two wires. Now I have connected the regulated power supply to the circuit. After that, I have to connect the current meter to the circuit. Only current meter symbol is present. Actual current meter is present here. That is why I have to connect externally. DCM stands for digital current meter. Negative terminal of the current meter, I am going to connect to the negative of the current meter. You can see the negative symbol here. And another terminal, I am going to connect to the positive terminal. So positive of the current meter, I am going to connect to the positive of the current meter. Then I have to connect DVM. DVM stands for digital voltmeter. I am going to connect positive of the digital voltmeter. You can see the symbol here, positive, to the positive of the voltmeter, and negative of the voltmeter. I am going to connect to the negative of the voltmeter. So I have connected current meter, voltmeter, and the power supply to the circuit, and I have to place this knob towards milliampere. So if it was to microampere, I have to move this to milliampere. Then after that, I have to insert the Zener diode to the circuit. You can see the Zener diode here. The terminal which is near to this black mark is called as negative terminal, and the remaining one is called as positive terminal. So since I am starting with forward bias, I have to connect the positive terminal to the positive end of the battery and the negative terminal to the negative terminal of the battery. So I am going to connect like this so that the Zener diode positive terminal is connected to the positive terminal of the battery, negative is connected to the negative terminal of the battery. So it is forward biased now. Now I have to calculate or I have to study the IV characteristics of this Zener diode under forward bias condition. Now I am going to switch on the instrument. When we switch on, voltmeter value, that is voltage value, is 0 and current value is also 0. Now slowly I will increase the voltage value and corresponding current value I am going to tabulate. So for forward bias I am going to increase the voltage value in steps of 0.1 volts. Now the value is 0.1 volts and the value of current is 0. Again, what I am going to do is I am going to increase to 0.2 volts. Again, the current value is 0 milliampere. So again, I am going to increase to 0.3. It is 0.4. It is 0.5. 0.6. I am going to increase 0.7. Almost it slightly increased maybe you can write it as no, still it is 0, 0.7, it is still 0. When you increase to 0.8, when you increase to 0.8, the voltage value, the corresponding current value shows as 1.8. So we have to record the value. When it starts increasing from 0.80, you can slowly increase the value, right? Up to 0.8, you can increase the voltage value in steps of 0.1 volts. After 0.8, you can increase the value slowly. So you can set to 0.82, then record the reading. Then again you set to 0.84, then record the corresponding current meter value. Likewise, you can go up to 0.86, right? So 10.1. So write down the or tabulate the value here like this, right? So you can go for up to 0.88 also. So tabulate the values. Voltage versus current. This is the values corresponding to forward bias. For reverse bias, there is only one change. You switch off, you turn these values to knobs to a minimum value, and then for reverse bias characteristics, switch off this instrument. You have to reverse the terminals. That means negative terminal of the Zener diode should be connected to the positive terminal, and the positive terminal should be connected to the negative terminal of the battery. Now, after the connection, you switch on the instrument. Now, our aim is to study the IV characteristics for the Zener diode under reverse bias condition. So, you make these two knobs, you ensure whether these two knobs are at minimum. So, they are at minimum, so that you can write down before starting the experiment. You can write down it as 0 and 0, current value and voltage value are 0. Now what I am going to do is I am going to increase the voltage values in steps of 1 mode, and I am going to record the corresponding current value when we connected the Zener diode under reverse bias condition, right? So I am going to increase the voltage value to 1. Right, to 1. When the voltage value is 1, still the current value is 0. You set it for 2. The current value is 0. You set it for 3. The current value is 0. Set it for 4, the current value is 0. Right? 5, 0. 6, 0. 7, 0. 8, 0. 9, 0. 10, 0. 11, 0. 11.5. Yeah. See, you can observe that 11 is also 0. 11.5 is also 0. Right? When it reaches 12, there is a sudden increase of current value. So after 11, you can set the values to 11.5. Then after 11.5, you can set the values to 12. Then you can set the values to 12.5. Right? Up to 12.5, you can do the experiment. Yeah. So record the values. After 11, you set it for 11.5 and record down the values of current meter. And after 11.5, you set it for 12 and the corresponding value you note down. And subsequently for 12 and 12.5 volts. Right? So this is the tabulated values for reverse bias. So 0, 1, 2 until 11. From 11, you have to increase the values in steps of 0.5, right? And then tabulate the values. After studying the IV characteristics, you have to plot a graph, right? So this is the IV characteristics for Zener diode. In the first quadrant, you have to plot the values of the forward bias. And in the third quadrant, you have to plot the values of reverse bias. When you plot the values, you're going to get a curve like this and draw tangent to the curve. And this tangent meets at a point along the x-axis. That value is called as knee voltage. Then calculate the slope of this straight line. Then you are going to get some value of slope. 1 by slope of that value gives rise to forward resistance of the Zener diode. Then after calculation for the forward bias is completed, you have to plot a graph for reverse bias. So this is the curve for the reverse bias. You have to extrapolate this linear part, and this linear portion touches the x-axis. That point is called as breakdown voltage. And write down the result as knee voltage is the first result, and the later breakdown voltage, finally forward resistance. So by plotting the curves for forward bias and reverse bias, you can calculate the knee voltage, breakdown voltage, and forward resistance for the given Zener diode.